We're now looking at heating pipework and components. This is the first part of two. At the end of this part of the session, I want you all to be able to describe the key differences between sealed and open vented systems, state the names, positions and minimum pipe sizes of heating pipework. Okay, so what we're going to look at today is the key terminology for the unit, pipe sizes, positions for the open vent pipe, as well as the insulation requirements for pipework right at the end of the session. So key terminology, primary water. Okay, primary water is the water in the heating side. If we talk about the primary pipework, we're talking about the pipework on the heating side. We can see in here, we've got a feed and expansion system here with the primary cold feed coming from that, which is filling up the heating side essentially. Primary flow and return would go to the cylinder and return back to the boiler, but it would go through the coil, and that coil would then be used to heat up the secondary water. A good way to think about it is, as you think, the primary water gets heated first, the secondary water gets heated second. So if you do have a system in which you have a separate cylinder, it's going to be called the secondary water, but also equally it's going to be called the secondary water in a combi boiler as well. The hot water that comes out of the taps will always be called the secondary water, or the secondary pipework is a hot water pipework, whereas a primary pipework is the heating pipework. But a good way to remember it, like I say, is if you imagine you have a system like this, a primary water is heated first, it's then circulated through the coil, and that heats up the secondary water. But everything on the heating side would be described as being on the primary side, and everything on the hot water side would be described as being on the secondary side. So yeah, sealed systems would have things like an expansion vessel built in, expansion relief valve, temperature pressure relief valves as appropriate, and particularly with heating systems, sealed heating systems must be filled through a filling loop. And the reason for that is actually it's a backflow prevention measure. Heating systems contain chemicals. They're considered to be, domestic heating systems are considered to be a category 3 risk. But these chemicals are potentially quite dangerous if they got back into our water supply. So alongside a double check valve, any connection to the heating system should be made via a filling loop, which should actually be removed as soon as the system is filled. I'm going to look at them in a little bit more detail in the next part of the session. So open vented systems, open vented systems would be fed from and vent to a system. We've looked at them in the hot water module already, but we'll look at them again now from a slightly different angle, from the point of view of an open vented heating system, but there's a lot of overlap. And you can actually sort of see a lot of the key information on this picture actually. The primary open vent, which is a vent pipe on the heating side, would be normally we'd use a 22mm pipe size, but the minimum set out in the regulations is 19mm internal diameter, worth noting. Okay, should rise above the feed and expansion system by at least 450mm, and that's to minimise the chance of pumping over, like I think we've mentioned in the last session. The primary cold feed is a minimum of 15mm, whereas a secondary cold feed is a minimum of 22mm. So that's something worth noting. There's a difference there. Primary cold feed minimum of 15mm, and we must not have any valves fitted on the primary cold feed. And again, we've got a primary flow and return, which as it goes out to the cylinder would be a minimum of 22mm or 28mm if it's solid fuel. Normally we wouldn't go smaller than 8mm to individual radiators. Briefly, going to look at filling an open vented system. Firstly, by looking at a single feed indirect cylinder. Very, very rarely are we ever going to come across these. or use these, but it's worth being aware of them because guilds have asked about them in the past. So a single feed indirect cylinder is a cylinder in which it has a heat exchanger which has got a hole in it, which allows water from the cold water storage system to fill up our primary side, something that we really don't normally come across. Normally it would be a sort of known as a double feed system, in which you'd have a cold water storage system which would fill up the hot water cylinder, and a separate feed and expansion system which would fill up the heating side. But if it talks about a single feed indirect cylinder, we would know that the storage system, cold water storage system, would fill both the hot water cylinder and the primary side, but we shouldn't fit these from new anymore. Okay. Essentially, you can sort of see how it works here. As the sort of water flows into the cylinder, it sort of bubbles up into the heat exchanger, fills up the heat exchanger, and then as the water is heated up, it causes an air bubble to sort of expand, and then it keeps the primary and secondary water separate. So therefore it's an indirect cylinder because the primary and secondary water are kept separate. But it's a single feed indirect cylinder because you have one cold water storage system which fills both the cylinder and the primary side. Okay. Worth noting, if the heating system overheats, it would vent into the cylinder, so you must not use chemical inhibitor if a single feed indirect cylinder is installed. Double feed indirect cylinder, you can see on this picture here, we're going to have the cold feed going into the bottom here, or a vent and distribution pipe coming off at the top. The reason we'd have it like this is because hot water rises, so we're always going to have the hottest water at the top of the cylinder and the coldest water at the bottom of the cylinder, and therefore we obviously want to draw off the water at its hottest point. So we put the vent and distribution pipe from the top and the cold feed, which is going to put in cold water to be heated, in at the bottom. Okay, primary flow in return is going to be 22 mil and is going to be connected into a coil like you can see here. Key thing worth noting is for the double feed indirect cylinder, you'd have a cold water storage system and a separate feed and expansion system to fill the primary side, like you can see here. All the key sizes again: primary cold feed minimum 15 mil, must have no valves fitted on it. Primary open vent 19 mil internal diameter minimum, or 22 mil pipe normally. Prices above 450 mil above the feed and expansion system, etc, etc. Okay. Yeah. Secondary cold feed minimum 22 mil, must have a valve fitted on it. Primary minimum 15, must not have any valves fitted on it. Very briefly look at feed and expansion system. This is what feeds the system and allows for thermal expansion. Just like the cold water storage system, it must be fully supported across its base with an extra 150 mil on all edges. So it would be supported just the way a cold water storage system should be. Minimum capacity for a feed and expansion system is 18 litres actual capacity, but it must be sized so it can take up to 4% of the volume of the water in the system, because that is how much water expands when it's heated. It will expand at 4% when it gets heated from say 4 degrees to say 80 odd degrees. So we need to make sure that the feed and expansion system is sized to accommodate that expansion. We also need to make sure that we set the float valve appropriately to accommodate for the expansion. If you set the float valve too high and then the water heats up and expands, it will expand, it will rise up, and the water will go out the overflow. And then as soon as the system cools down again, the water level will drop, the float operated valve will open and take the water level back up to where it was originally, and then next time it heats up, it will overflow. So you need to be a little bit sensible about how you set the float operated valve. You'd want to set the float operated valve quite low in the feed and expansion system to accommodate for that system water expansion. Okay. Worth noting that if you've got a double feed indirect cylinder that's fed from a cold water storage system, you'd want to position the feeding expansion a little bit lower than the cold water storage system, and that's essentially just in case the cylinder coil leaks. And that would mean that the water would push in from the hot water side and sort of cause the feeding expansion system to overflow, rather than water from the feeding expansion system or the heating system being at a higher pressure and pushing out into the hot water side, which could potentially be a contamination risk. So primary cold feed, as we've talked about a couple of times already, minimum of 15 mil, must not have any means of isolation on it. It comes from the feeding expansion system, and it feeds the heating side. Okay, worth noting, if you do need to isolate the water to an open vented heating system, you turn off the valve before the feeding expansion system. So this valve just here, you can see, turn it off there and then before you drain it down. Worth noting as well, actually, the primary cold feed is described as the neutral point in the system, and it's the position after which you should position your pump. But we're going to talk about that in a bit more detail later on. So a primary open vent pipe is the pipe which is coming from the heating system, because it's on the primary side, and it would rise above the water level in the feeding expansion system by at least 450 mil, minimum size 22 mil. Its purpose there is actually, under normal working conditions, it's to just keep the system at atmospheric pressure. But in fault conditions, it would allow water to escape the system if it overheats. Minimum internal diameter 19 mil or 22 mil. Primary flow and return. Primary flow and return to the cylinder would normally be a minimum of 22 mil or 28 mil if it's a solid fuel boiler. And the main runs to the radiators, the main runs would be in 22 mil, and then it would be split down to whatever size the radiator is appropriate for the radiators. Quite often we'd use 15 mil running to individual radiators, but you could use microbore, you could use 10 mil or 8 mil to radiators quite, and it would heat up quite adequately. Insulating heating systems. Excuse me. The requirements for insulating heating systems laid out in Part L of the building regulations, which is this law, and its supplementary guidance, the Building Services Compliance Guide. It tells us actually that ideally all primary pipework should be insulated, but you do need to pay particular attention where pipework runs in unheated areas, like in the loft space or garage or under a suspended floor. Okay, there's different types of pipe insulation. There's a few that we need to be aware of. We've got foil-backed fiberglass here, which you can see, expanded polyethylene and expanded nitrile rubber. All of these are quite fine to use on heating pipework. Very briefly look at draining heating systems. If you do need to drain heating systems, then the procedure would be make sure you turn it off at the appropriate point. With an open vented system, that would be at the flow operated valve to the F&E system. With sealed heating systems, you don't actually need to turn off the water supply anywhere because it doesn't automatically fill. But yeah, then make sure that you find the appropriate point to drain, which obviously is going to be at the low point of the system. Make sure you turn off the heating system before you drain it, and you leave notices so people don't turn it back on. Wait till the system is cool before draining, and then you'd let the water out. Worth noting that you would also need to let air in. You'd go around the radiators starting from the top floor, open up the bleed valves, which allows air in, which essentially allows the water out. It stops the water being trapped in the radiators because they're in a vacuum essentially. Now it's time for your task.